Hello friends. So in this video, we'll solve a few questions on inverse trigonometric functions. So the first question is, show that 2 tan inverse of half plus tan inverse of 1 by 7 is equal to tan inverse of 31 by 17. Now the usual way is to go from left hand side to right hand side. So we'll see how to do it that way. Okay. Now we use two different formulae here. First is both are actually related and the one is just a simplification of the other. So the formula, I'm going to write the formula here. The formula is tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B by 1 minus AB. Now there are a few cases here which you'll have to consider, which you'll have to yourself see. Now first of all, if you see that A and B both are greater than 1, or there's some, if the product is greater than 1, then you know that tan inverse of A will be greater than pi by 4, and so will be tan inverse of B. So the sum must be greater than tan of pi by 2, right? But when you write tan inverse, you take the principal angle to be between minus pi by 2 to pi by 2. In which case you will get a slightly wrong answer, right? So what you need to do in that case is slightly modify this problem, and that it will read actually pi plus tan inverse of A plus B by 1 minus AB, right? So we see that here in the first case 2 times tan inverse of half, so no, the product is less than 1, so we'll just take this formula and A is equal to B, so you get a fairly simple one. So LHS will be tan inverse of 2 times half divided 1 minus half squared, right? Plus tan inverse of 1 by 7. So this makes it 2 into half is 1 by 1 minus 1 by 4, that is 3 by 4 in the denominator, makes it tan inverse of 4 by 3 plus tan inverse of 1 by 7, right? Now again we can use the above mentioned formula and we get tan inverse of 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7, right? So which gives us on simplification tan inverse of, that is 28 plus 3, that's 31 by 17 in the numerator, and 1 minus 4 by 21, that is, it's 31 by 21 and 17 by 21, right? So we get tan inverse of 31 by 17 equal to right hand side, right? So we see that we just need to repeatedly use the tan inverse, sum of tan inverse formula, and we get the required answer. So the next question is, solve 2 tan inverse of cos x equal to tan inverse of 2 cosecant x. Now again we see 2 times tan inverse, so we use the same formula as the same formula used in the previous question. So this is tan inverse of 2 cos x divided by 1 minus cos squared x, right? That is equal to tan inverse of 2. Now what is cosecant x? Cosecant x is actually 1 minus 1 by sin x, right? Now we know that tan inverse of A equal to tan inverse of B means A equal to B, right? So writing that way we get 2 cos x by sin squared x is equal to 2 by sin x. Now since sin x is in the denominator, it cannot be 0, and so we can cancel it, and the 2 also cancels, leaving us cot x, right? Cos x by sin x, which is cot x, equal to 1. Now what does that mean? Cot x equal to 1 means, so that is our solution, right? Cot x is equal to 1. Now the question asks for x, so we will just write the general solution of cot x equal to 1, which gives us x is equal to n pi plus pi by 4. Right? So this is general solution of x. Okay. So the next one. Okay. The next one says evaluate tan of half cos inverse of root pi by 3. Right. So till now we had 2 times tan inverse, but here we have tan of something. Inside the argument we have cos inverse. So I'll just show you how to make this question a whole lot simpler. Okay. So we cleverly write half of cos inverse of root pi by 3 as theta, right? So that the argument becomes just theta. We have tan theta, and once we find out tan theta or any other trigonometric function, say instead of tan theta, we can find out tan theta in terms of that, right? So it's better if we just take the whole thing as theta. So what is cos inverse of root pi by 3? Cos inverse of root pi by 3 will be 2 theta. So that means cos 2 theta is root pi by 3. Right? Now let's write cos square and sin square in terms of this. Cos 2 theta is actually 2 forms in sin square and cos square theta terms. So, for cos square theta, it will be 2 cos square theta equal to 1 plus root 5 by 3. That is 3 plus root 5 by 3. Similarly, for 2 sin square theta, this is 1 minus root 5 by 3, giving us 3 minus root 5 by 3. Right? So let's just divide these equations. So on the left hand side we will have tan square theta, on the right hand side we have some numeral, right? So we see that our question actually becomes very simple. We just need to divide the right hand side. Okay, so tan square theta is tan square theta is 3 minus root 5 by 3 plus root 5, right? Okay, so let's rationalize it. Rationalize the denominator. So we have 3 minus root 5 into 3 minus root 5, so 3 minus root 5 squared by 3 squared minus 5. Okay, so that gives us 3 minus root 5 squared by 4. That is the tan square theta. Okay. So the question asks this tan of theta. So tan theta, which is equal to tan of half cos inverse of root 5 by 3. Okay, root 5 by 3. So that is equal to 3 minus root 5 by 3. This is the answer. So we see that we can cleverly manipulate the argument inside so as to suit us, and we did that by taking the whole thing as theta and then finding some trigonometric functions in case of 2 theta. After this, the next one. So this question says solve 4 sin inverse x plus cos inverse x is equal to 5. Now just like cos inverse x, cos square theta plus sin square theta equal to 1, we have another universal identity that says sin inverse of x plus cos inverse of x is equal to pi by 2, right? So substituting this or just subtracting one equation from the other, we can eliminate cos inverse of x, and what we get is 3 sin inverse x is equal to pi by 2, right? So sin inverse of x is equal to pi by 6. Now that we know this, we can just write x is equal to sin pi by 6 or half. Right? So here we use the universal identity and solve this question. So the next question, find the value of secant square tan inverse of 2 plus cos square of cot inverse of 3, right? So let's take these terms one by one. So first we have secant squared of tan inverse of 2, but secant squared of anything, right? So let tan inverse of 2 be theta, right? So secant square theta is 1 plus tan square theta. So this is 1 plus tan square of, but theta is our tan inverse of half, right? Tan inverse of 2, sorry. So now tan of tan inverse of 2 is 2. So tan squared of tan inverse of 2 will be 2 squared, that is 4. So this is 5. Similarly, cosecant squared of cot inverse of 3 is 1 plus cot square of cot inverse of 3. Right? Exactly the same thing, same thought process here. So that gives us cot square of cot inverse of 3 as 3 squared, which is 9. 1 added to that gives us 10. Hence, secant squared tan inverse 2 plus cosecant squared cot inverse of 3 is equal to 5 plus 10 equal to 15. Right? Okay. So that concludes our question answer session here. So we saw a few questions. We first revised trigonometric equations and saw how which method to use in a specific equation. Apart from this, we also solved a few questions. Okay, so in the next videos, we'll be learning more about algebra. Thank you.